Hi guys, thanks for joining us again today. I'm Ben, I'm build captain with Arksen, ably joined again by my good friend and colleague Jim, our technical director. We were so pleased to see the level of engagement we had with our walkthrough video with Jasper. Reading some of the comments, there was quite a few people who were looking for a bit more of a deep dive into some of the engineering aspects on board. So today we're going to be taking a tour through the engine room, really diving into some of the nitty-gritty about the engineering aspects of the boat, and I'll be posing my questions from an operator's perspective on one of these vessels. So please come and join us in the engine room right now. Thanks for joining us today on board, Jim.
No worries.
Obviously, we're going to run through some of the items in the engine room and see what it is about some of the design philosophy behind this. So first thing, obviously, we've got in shot here is our Halyard exhaust system. What was it that kind of informed the choice, and why did we decide to go with this system as opposed to any of the others?
So we worked with Halyard a lot in the past on all sorts of projects, and yeah, it's a really great system, and it's a robust commercial system, as with much of what we're doing on here. So it's a wet exhaust system, as you can see. Got the dry exhaust coming up and over, and that's very deliberately routed high up into the deckhead like that. Just to eliminate any chance of there being any sort of backflooding of water or anything like that, coming down into a spray head and then into a silencer separator. And it basically means that we're sending exhaust gas over the side above the waterline, and the used cooling water below the waterline, just to reduce the noise, basically.
Okay.
We have an option with that for boats that might be spending a bit more time in high latitudes, where you can have a diverter there. So you can also choose to send the water over the side above the waterline. If you've got any icing, that sort of thing, you can bypass that.
Yeah.
So it's not something we've done on this one, but it's something we expect to do on.
Well, that's a brilliant example, actually. So you know, I'm aware that a lot of features that have been incorporated into the design are to enable these boats to go further and farther than a lot of other boats within the class. So that's some of the things we'll touch on, but just talking about some of the specifics here, and for those that maybe aren't quite so familiar, obviously we've got all this lagging around the pipe work here. Just talk us through a little bit about what the lagging, why we chose this form of lagging, and what its function is.
So primarily its function is to reduce heat load going into the engine room from hot exhaust pipes, but also obviously from a safety perspective.
Yeah.
You know, particularly like this, it's very difficult on a boat of this size to design these sort of routes so that you can completely avoid people. You're going to be ducking under it just to basically to stop yourself getting burnt. But this particular product is just a really nice, durable product that looks quite presentable. And there are some alternatives that just are less durable in time, like foil-based things and things like that. They flake and they start looking a bit messy. So.
And this is nice, actually. You know, I'm glad you brought that up, because certainly a lot of the boats I've worked on in the past, we have kind of the foil lagging, and it's the bane of the engineer's life, actually. You come in here and give it a few years, and you start getting chunks peeling off, and not only does it look messy, but it's actually going to lose some of its effectiveness as well.
Yeah, and just creates mess and looks, from an owner's perspective, it makes their lovely engine room start looking a little bit rough around the edges.
So I think one of the things that's really important to address as we're kind of going around here is often the devil's in the detail in some of those unseen things. But from my perspective as an operator, what gives me a lot of confidence here, seeing we've got 316 stainless and double hose clamps on everything. What can be some of the issues that I know certainly I've seen some issues before when you're using lower grade stainless?
Yeah, you do sometimes see lower grades of stainless and sometimes even steel being used, and there's obviously a corrosion issue there. These are also bolt clamps rather than Jubilee clips, and it's good practice. It's something that any good yard should be doing, but it's something we make sure we're doing everywhere.
I certainly see on as mentioned before, some of the boats I've worked on, they can be a really very expensive, very gorgeous looking boat from the outside, but actually when you start to scratch beneath the surface, you can see where costs have been cut in places. And it's little things like this, which may not seem like a big factor, but everything, all the materials and equipment we've used, and one of the things I love so much about the Arksen vessels is it's using the right equipment without being overly concerned with trying to cut costs and corners.
Yeah, and you'll see that all over. It's a good example of a small detail that one of many of its type, and one of many other small details where a boat that's not designed to sit in a marina for most of its life, it's a boat that's designed to be out there exploring. An owner and captain just shouldn't have to think about this sort of thing, But it's also the sort of thing that, as your evidence of, that people do notice that, and we speak to a lot of captains, owners, representatives, engineers who come on board and look on board on behalf of their clients. And they notice and they see, the amount of metallic pipework we use, for instance.
That was one of the things I wanted to raise, actually. I noticed there's very little in the way of flexible hosing, and most of the pipework in this engine bay is metal hose. Now, I'm aware, obviously, there's not necessarily a requirement to use metal pipework as long as the rubber hosing is of the correct grade from a safety and a fire perspective. Where was the decision just to use some of the to run most of the pipework through the engine in metal?
You're right. It's not a requirement under the rules that this boat is built to. However, it's a class requirement, and as with a lot of things to do with the way that we build the boats, we follow class requirements which are usually applied to bigger boats or to commercial boats to build in that level of robustness.
Going above what's needed, go above and beyond the minimum requirement.
All this pipework here could be. Could be flexible hose, and as long as it's an approved hose, that's fine. And you'll see we use little short lengths of flexible hose, and that's just because particularly things that are vibrating, things that expand and contract with heat, things that would be difficult to directly connect a solid pipe to, you have to have this transition, and that's fairly common on big boats as well. And
I think from an engineering perspective as well, it certainly makes fault identification, if you do end up having a bit of a loss of pressure in a system somewhere. Certainly, again, back to a lot of the boats I work on where you've got a lot of flexible hosing, you can have the tiniest little leak somewhere along that pipework. What I like to see here is, chances are, if you've got a bit of a loss of pressure somewhere, it's probably in some of the rubber hosing,
either in a hose or in a hose connection.
Exactly.
We've had it on this boat in commissioning. We had a hydraulic leak, and not just a little dribble, and it was coming out of where a flexible hydraulic hose connects to the rest of the stainless pipework, and very easy to deal with. All of the solid pipework has been pressure tested rigorously to the shipyard standards. So, we come into it having a high degree of confidence that if there is a drop in pressure or a leak, that it's not coming from there.
And it's easy to find because you've only got a few of these sections. That's fantastic. Exactly. Well, thanks, Jim. Moving a bit further around in the engine room here on the port side of the aft section where we are, obviously we've got the sewage treatment plant. Super important section, perhaps something that isn't talked about in great detail sometimes, but back to the point of when you're operating these boats, whether that be in an environmental zone or in a beautiful clear water anchorage and things like that, it's not necessarily just about following MARPOL regulations as to where you can discharge and things like that. There might be areas where you can discharge raw sewage into an area, but do you really want to be doing that?
No, and having a sewage treatment plant gives us that flexibility. Yeah, as you say, you can be discharging in certain areas, but there might be an area where you just don't want to, and we have the capacity to store that on board. So if you're as per your example, if you're going into a nice clear anchorage, you want to go for a swim, or it's an environmentally sensitive area, you can just hold all of that on board.
And when the time comes, though, obviously there is a limited capacity, and I'm aware the tank capacity for the black and the grey water on these boats is kind of much greater than you might find on a similar size vessel for exactly those reasons, and having that extended ability to operate independently. But when the time comes and you're clear, you're outside your 12-mile limit and you want to be discharging again, just talk me through the operation of this system.
So this basically means that you can be discharging treated sewage matter whilst holding on board solids. So it comes back to MARPOL, and it means that sewage is macerated by the macerator toilets on board, and then is held in the holding tanks. And then when you want to treat it and discharge, it's basically pumped through this machine, and this machine is, in a nutshell, it's basically injecting compressed air into that macerated sewage, along with a flocculant chemical, and that chemical binds the solids within that together, and the compressed air brings it together and floats it to the surface of the chamber here. And at the top there, the solids overflow, and they're then pumped into this sludge tank.
Yeah.
There's 500 litre capacity there of sludge, which, given the tiny amount of sludge that has actually
The actual solids that are left once you've separated that from the wastewater that comes down from the heads.
Correct. The percentage that's kept on board is minuscule, so it takes a lot to fill this tank up, and then the remaining liquid is then sterilised.
I wanted to talk about this. I noticed we've actually got a UV steriliser on here, which is something for a vessel of this size. It's quite special, really, isn't it?
Yeah, it just means that then all of that liquid is sterilised. So when that then goes overboard, it's sterile and and safe to discharge well within MARPOL limits. And then at the next available opportunity, you can pump your sludge tank ashore, and that's how this works. And it just gives us lots of flexibility. Goes the extra mile in terms of what we need to be doing versus what we want to be doing.
And I think one of the things that I particularly enjoy about this engine room is everything is just to hand, and access isn't an issue. I'm going to keep coming back to the point. Here we are, an 85-foot vessel, and working in this engine space is far more capacious than other vessels I've worked on of a larger size. And that just the ability it gives you here as we look through all of this, you've got access to all these connectors. And where did what kind of informed that level of functionality when you were looking at specifying the design and how this was going to be put together?
So as an overriding design requirement, when we first started, we were like, okay, right, we've got a specification, we know the equipment that's got to fit into this engine room. There is a limit to what we can fit in here, but we made sure we'd left enough space without giving it all over to interior. Is making sure that everything is accessible for maintenance, everything is accessible for fault finding, repair, anything that needs to be accessed can be accessed as best as practically possible. So as you say here, this is something where, particularly this piece of equipment, if you're working, you don't want to be upside down in a bilge trying to get spanners onto things. And
the sewage treatment is often so often one of those areas that does get tucked away into a bilge compartment somewhere with very little access around it, because it's seen maybe as a secondary system. It's not a sort of mission critical. If your sewage plant, treatment plant goes down, it's a case of, well, we need to get that repaired, and perhaps you might need to go into a shipyard to do that. You might need to remove some sections of panelling. And I think that sits so nicely with the rest of the philosophy of the design here, which is trying to keep that independence and not needing to go into a shipyard and have works done.
Yep. Exactly. The key philosophy there is autonomy and not having to operate near a shipyard. And so and we'll see as we go around, everything is very easy to access. There's plenty of space around everything. You can quite clearly see with everything what's going on and how you get to it. And if there's a leak, you can see it and get to it.
Fantastic. Okay. Shall we move around a little bit further into the engine room? I want to talk about some of the hydraulic power packs on the boat. Obviously, we've got one system here. I'm aware as well. Obviously, the main hydraulic system on this boat, quite standard, is you've got power takeoffs and PTOs from both gearboxes. So you've got and one of the things that we've kind of talked about before is the redundancy that you have within these boats. So just remind me again of the what sort of level of hydraulic, what can we run if we were just say using one PTO?
So there are there are three pieces of equipment on board which are hydraulic. If we ignore the steering from this conversation, which is obviously a separate system. There's a bow thruster and two anchor windlasses. So we have main hydraulic power provided by a PTO pump, which is clutched off each gearbox. And each PTO pump is capable of powering the bow thruster, which is the biggest consumer of hydraulic power, at full power at idle. So each one of those can do that. So
at idle as well.
At idle.
That's really impressive, actually. I mean, generally, I'll find you normally need to kind of have a few revs on the main engines to put enough pressure through the
that's
PTO.
quite common, yeah, and exactly. So
That's a nice touch.
So that's the reason we've done that. If you're manoeuvring, you're not having to worry about clutching in, clutching out, to play with your revs. You can just use the thruster at full power, and it's basically a standby and duty configuration. So you periodically, maybe every couple of weeks or whatever, you would swap over the pump that you're using. But yeah, each one is capable of doing that job.
So if you have a problem within one system, for example, you've got the other one as complete backup, which is great. And say you've got some problems, a fueling issue or something like that, and you're in a position where you're anchored, and you want to be able to either lay out some chain, take in a bit of chain. Now, obviously, whether you've got an issue or not, or whether it's the middle of the night, there's going to be times you're not going to want to be firing up one of the main engines and kind of having that noise and vibration and exhaust, etc. Kind of brings us on to the power pack here, doesn't it?
Yeah. So this is the overall reservoir for the whole hydraulic system, and we've put an electric pump into that. So
it's a beast as well.
It's got a bit of a monster motor on it, and it basically means if that's the example you raised there. If it's the middle of the night, you don't want to have to be starting up an engine to get hydraulic power. You can just turn on your electric HPU, and that will give you enough power to operate your anchor windlass. So if you just need to pull in a little bit of chain, you can do without having to fire up the engine. So.
Fantastic. And in terms of this system as well, is that going to allow people as they spec these boats, if they're going to have other elements that are going to be running off hydraulics as well, is that going to give it additional capacity?
Yeah. So for instance, if someone opted to have a deck crane, that could work off this system. So
brilliant.
The pressure and the pressure and the flow specifications of this system are sufficiently high that they cover any of our optional hydraulic piece of equipment, whether that be a telescopic passerelle or a crane or hydraulic door or whatever. This will handle that. And then you've therefore got multiple means of redundancy there as well. So for instance, if for whatever reason you couldn't use your main PTOs, you could retrieve the load on a crane with the electric one, or you could retrieve your anchor chain with the electric one. There's that ultimate redundancy.
Brilliant. And so you're saying on this boat specifically, we've got a manifold then that sits up in the forepeak area as well, so you can kind of divert flow as needed. Yeah,
basically it just means it reduces the amount of pipe work you've got going up through the interior, from a noise and vibration perspective, and from a simplicity of routing. It means
you certainly don't want to have a leak anywhere in I've been on boats before. You get a little bit on that high pressure hydraulic system. If you've got hydraulics running all throughout the boat and you get a little tiny leak.
Exactly, and it comes back to our point earlier on about solid pipe work. It means you've then got a manifold in the bow, one from that, all of your various sort of A and B hoses and drains and things like that to motors for windlasses or bow thrusters. That all goes on in the bow.
And I'm going to touch on the point again, but just the access that you've got to this system here and your connectors, etc. You're not going to be worried about trying to throw a spanner back and forth on here. You've got loads of room to throw spanners.
Especially with this, where on the sort of the support, the suction pipes to the pumps, so they've got these enormous fittings on them, so you need to get some pretty big spanners in there, and really easy to get to.
Just while we're here, because I know we're going to talk on the fuel system in a moment, but helping our friends here who are kind of filming us, I think it's going to make sense to probably touch on what looks to be quite an old-fashioned system here.
What is that? Yeah.
So I mean, I'm aware of what this is, but for the viewers at home, you just want to run us through what our vintage pump is.
So working on the fuel system, working backwards from worst case scenario, that your two different means of electrically pumping fuel for whatever reason are out of service. You have a manual pump, so basically you can see this is on just quick connections into the system, so you can connect it and disconnect it as needed. It's connected at the moment actually, but and it just means that you can still pump from any fuel tank to any fuel tank.
Okay, so that's not just pulling from one tank into a day tank, for example. You can move fuel all around the system. Yeah. As long as you've got calories and muscle strength in your arm to actually pump on this.
A bit of elbow grease, yeah. So you can still do that. I mean, I think ultimately it would be if you need someone to periodically come down and put a bit of fuel into the day tank so you can carry on running. But obviously it's just not going to happen. But if it does, you've got the.
And I think that that to me, in comparison to a lot of other vessels I've worked on before, that really stood out from the moment I started to get interested in the Arksen 85 projects. Was it's those tiny little what ifs, it's probably not going to happen type scenario, where a lot of other manufacturers might say, well, it's probably not going to happen, we don't need to provide for that.
There isn't a rule requirement for it. Yeah.
Exactly.
Yeah.
And whereas just small things like this, it may seem like quite a minor thing, and for 99% of the use case on the boat, but you know what, for that 1% of time, you're going to be bloody lucky and pleased you've got this, right?
Yeah. Well, and you know, just flicking over back to the hydraulics and on the other boat we're building at the moment, which has a bit more hydraulic kit on it. You know, it's got a crane and a hydraulic bathing platform. That has a manual pump on it as well, that power pack. So again, it's got 2 different electric pumps in the hydraulic power pack, and a manual pump. So you know, if you know, it might take a while, but you could bring that piece of that, bring that crane back in, or whatever you need to do. Yeah. So yeah, similar sort of line of thought on that.
Great stuff. I think we're going to touch on the fuel system. I can see we've got the port day tank here with your sight glass on the side, and I particularly like to see this as well.
Yeah.
You know, is actually having that kind of analog means of checking your levels in tanks and things like that, and quite often.
Yes, nice practical feature. And it's just another opportunity to see your fuel as well. Which is always good.
Yeah, definitely. You can see the quality in there as well. But specifically coming around to the fuel transfer system as well. I mean, these looks like some pretty beastie filters that we've got as part of the fuel transfer filtration system. Just be able to talk us through a little bit of info around here?
Yeah, so we've there are 6 fuel tanks on board. We've got the 2 day tanks here in the engine room, and then we've got 4 bunker tanks underneath the interior. And with the transfer system that we have the ability to move fuel from any tank to any tank, whether that be moving fuel from a bunker tank to a day tank for use with the engines, or whether it be for balancing the boat. So you want to move some weight from port to starboard, you can do that using this system.
Fore and aft as well, get it trimmed
fore and aft,
yeah.
Absolutely. And another aspect of that, as you point out, is the filtration side. So in normal operation, that would be if you were wanting to top up your day tanks, if you're on passage and you're just gradually running down your day tanks, you want to put some more fuel in, you transfer it via these filters, and that will filter out any particulates, any water, so that you're only getting clean fuel and dry fuel going to your day tanks.
And then that's great. So you know that the fuel coming from your bunker tanks into your day tanks would probably be at the state it would be good enough to run straight into your engines.
Yeah, I mean they're the same filters. They're just slightly bigger version of the same filters that are the primary filters for the engine.
Just because you're shifting that much more flow through them, right?
Yeah, and with tanks the size that we've got, you know, there is the chance you might pick up a little bit of condensation, for instance, if your tank, you're in the right conditions and your tanks aren't completely full or completely empty. So any of that water gets removed here, and then you can easily then collect that off and put it into your oily waste tank. Yeah, so that's basically that's overall the sort of the philosophy here.
But I think what's fantastic is you're going to have top quality fuel already in your day tank, so that anything coming through your sort of primary filters then before they start going to generators and main engines is already in a very good quality state. But then of course we've got the your primary fuel filter system down here as well with your water separators.
In duplex, so it's just layers and layers,
you're not having to necessarily, just for my understanding as well, would you be able to change out one of these filters whilst running?
Yeah.
And
exactly.
that's a great feature, because what you don't want is obviously desire to kind of change out your primary filters when you're mid-Atlantic, and it's all fine if it's nice and calm, you need to stop for half an hour, but certain conditions you're going to be in, you're not really going to want to have to shut down both your engines just to effect a filter change.
Exactly, or come down and do a filter change when it's in an uncomfortable scenario. You can just come down and change your filters over and carry on running until the next opportunity where it might be more suitable.
Yeah, and that's such a useful feature from an operator's perspective as well.
And having already filtered it and separated it through the bigger filters, it also means you're having to less frequently change out those, swap over or change out those filters. So you may also not want to change your actual filter element until you're next in a stopover. So yeah, that's what that's all about. When we're talking about the transfer system, there are two separate pumps here. So you have this smaller, lower volume pump here, which works with the filters, and then in addition to that, you have a larger fuel pump here, which is for instance, if you were wanting to shift large amounts of fuel quite quickly. Compared to this other pump between tanks. So for instance, you found that you had a bit of a list, you could quickly chuck a load of fuel from port to starboard or vice versa, or fore and aft from a trim control perspective.
Yeah, you're running downwind, you've got some big seas. You know, I'm aware these boats will actually, looking at some of the videos that produced from the Wolfson Institute, actually in the right conditions, this is a surfing hull, but you're certainly going to want to shove some weight aft if you're doing that.
And so you can do that. You know, you're
how quickly can you shift fuel around the tanks? What rough sort of flow rate are we looking
so that
at?
one's 200 litres a minute.
Fantastic, that's amazing.
This one's only 15 litres a minute, but that's based on how quickly you need to fill your day tanks, really.
Yeah.
So there are options to upgrade that to a bigger capacity if you really wanted to be filtering every time you move fuel. Then there are options for that. But in terms of just always ensuring you've got enough fuel in your day tanks, that's what that's based on.
But shifting, you know, being able to, I mean, I'm going to get shown up here with my poor grasp of weights and measures, but I mean, what we're talking sort of 200 litres a minute. We took about 180 kilos, something like that. 180 kilos a minute you can be shifting around in terms of ballast.
Yeah, no, thereabouts, yeah.
I mean, it's good enough, right?
Yeah.
That's why I'm a skipper, not an engineer.
Yeah.
Great to know you can be shifting that sort of volume of fuel. Again, from, I think from a day-to-day perspective, you may, like a lot of things we've talked about in here, on your average sort of daily use case, you may not really see and appreciate the benefit of this, but if you're in that situation where you really want to be moving a lot of ballast around your boat quickly, the ability to shove that amount of fuel around is such a comforting feature to have from a safety perspective. And you know, I think as probably all aware, my priority on board as the skipper and the captain of any vessel, number one priority is safety, and it's all fine until it's not. And then it's these little touches that I think really give you that confidence to go into those slightly more adverse situations, and that's the purpose of a boat like this, right?
Yep, 100%.
Onto a sort of more of a kind of comfort perspective. I've noticed this is a nice touch. We've got an air handler here for the aircon and the heating.
Yeah.
Was this an owner request?
It's not a standard feature, but it's something that the captain of this boat was quite keen to have it, because it's an air conditioning and heating unit on the same circuit as the rest of the air handlers on board.
So fabulous if you're doing some work in, you know, those hot Mediterranean climates or something like that in the midst of the summer. You need to come and do some work, got some contracts in here, to actually have some air conditioned air circulating around the engine room is that's
and
a
the more comfortable the space can be, the more likely your engineers are going to stay in here for a little bit longer, which can only be a good thing. So that's where that one came from. Same in the lazarette.
I just noticed as well, in this corner we get quite a good view of the fire, the heat and the sound insulation through this throughout the lining of the engine room. Now obviously fire retardant materials are required, etc. But what kind of informed some of the choices with how this was laid out on the Arksens?
Very simple, really. We decided that we should go for the standard, which gives the boat the best ability to be safe from a fire protection perspective. So that's A60 insulation there.
Right. Okay.
So it's
above and beyond
60-minute rated fire protection, which is way above and beyond the rule requirements for a boat of this size. And
that seems to be a bit of a theme that we're talking about with Arksen, right? You know, there's a requirement for the rule, which is what you need to do to keep you safe. We're generally, wherever there's a requirement, we're going above and beyond what's required.
The theory being that if you're operating in a remote area and you do, in the unlikely event that you do have a fire, you've got the maximum amount of time to deal with that situation in terms of fighting the fire, and also from a sort of a mustering perspective, you know, you've got a really good level of protection there, and we'll. In sort of subsequent videos, I'm sure we'll come on to the sort of the firefighting systems and things like that on board, but it's just all part of that.
Yeah.
And inherent to that is the thermal and acoustic insulation properties as well that come with that insulation. So the whole engine room is fully insulated to those A60 requirements, which inherently means this really high standard of insulation coverage and detailing. And it comes down to bulkhead penetrations and deck penetrations and things like that, how they're done.
I'm glad you brought me on to that, actually, Jim. I can see actually here through some of the watertight bulkheads. Back to your point around metal pipework, and I think you guys may have to get this on a close shot here, but looking down at how these bulkhead penetrations have been sealed. And what's lovely to see is you've got metal pipework running through those as well. Was that a very conscious choice?
So first of all, if we're going to say that regardless of what we need from a rule perspective, if we're going to say it's an A60 engine room, then we need to make sure that we're compliant with that. So from our own sort of technical due diligence, we're doing that properly. So the penetrations we're using are a fully class approved fire insulated and watertight penetration, so they have a number of sleeves going through them, which any cables or pipes can go through. Then that's all filled in with like a putty around there, which gives it its integrity. Some of them, there are some areas where there does have to be we might choose to, or there might have to be a plastic pipe going through.
Sure.
We do use plastic pipework elsewhere in the vessel, and where it's suitable to do so, but some of these penetrations are also sort of intumescent, so if there is a fire, they will literally crush that pipe and seal it off and seal the bulkhead at the same time. So, really,
it's reassuring, very reassuring from my perspective when we start operating these boats. There's one other point I wanted to touch on while we're in this corner, and actually, sorry, no, you mentioned we were going to come on to, in perhaps another video, we talk about the fire suppression system, but just briefly while we're in the engine space here, FN200?
No, we have StatX.
Oh, okay.
So this is one of the canisters here. So it's an aerosol fire suppressant. So it's inert. So it's from a safety perspective, you wouldn't want to be next to it when it goes off. But it's not a sort of a space flooding, ozone depleting.
Well, that's the key part.
So it's and from an installation and maintenance perspective, it's great. It's a canister with a cable going to it, and there are 4 of them in the engine room. There's one in the battery room on separate, and they're on separate zoned systems. And it's manually activated. There's nothing automatic about that. So in the event of a fire, you go through the checks that you might expect. Is there anyone in the engine room? Are the doors shut? Shut your ventilation. Turn your fans off.
You've been reading a bridge procedures guide.
There you go. Yeah.
You have my job before you know it, Jim.
Release the suppression system, and hopefully that deals with the fire. Then it's sort of a chemical reaction. I won't try and explain exactly how it works because I don't fully understand it myself.
Go on,
but there's a chemical reaction there that basically puts that fire out and importantly prevents it from reoccurring. It doesn't leave a load of powder or any sort of gunk all over your equipment. And
if it's a false alarm and your engines are running, you're not going to run the risk of damage to your engines with drawing into the combustion system.
For a sort of a one-time event like that,
you're not going to want to do it regularly.
It's not going to do. It's not going to do any damage. But that's got all the approvals and as you would expect.
Fantastic. Thanks, Jim. To the untrained eye, obviously, we're sitting here looking at some big white boxes with a couple of switches in. I mean, what?
That's all it is, really.
Yeah. So obviously we've got power distribution going through here, and all our circuit breakers and everything you could do through the IMAX system, through the panels that we have throughout the boat. I think it's important to touch on the fact that you've got manual control of everything should you need it or should you want it by actually coming down into these panels. So just talk us through a little bit of what we've got going on in these panels.
Yeah, so this is the main switchboard. So just from a high level within here, we've got our AC distribution, our DC distribution feeds off to emergency switchboards, and a couple of sort of localized distribution boards under consoles and things like that. But generally, everything is centralized here. And as you pointed out there, this is also the sort of the central hub for the IMAX digital switching alarm and monitoring system. And we were quite keen to bring as much together as possible into one place. So whether you're just generally kind of inspecting and managing things on board, or whether you're trying to chase down a fault in future, everything's together in the same place. As you say, the digital switching system obviously has a lot of control of the functionality of pumps, valves, fans, lights, all sorts of things. If for some reason that digital system was to go down, you can come down here and you've got a manual switch for the main things, and a breaker, and then various breakers for other parts of that. So you have the ability to come out of that automatic kind of digital switching mode and just into an old-fashioned breaker or switch mode. Yeah. So as an example, you can see here that you've got a number of switches here which either have an auto or an on mode. So on mode is I'm turning that thing on, so that pump will run. Auto mode is, right, that's in control of the digital system. And as an example, here we have one switch illuminated, which is for the battery ventilation, which shows that that's on, being controlled by the digital switching system. That's why that's illuminated. And you've got a similar looking panel down here for the DC side of things. So yeah, manual control as well as that automatic control, which is a really key thing to a lot of operators for good reason.
Definitely, and I think especially as time goes on and we start to see more levels of automation and system integration into touchscreens and panels, that's fantastic. But we've got to bear in mind we've got complex electronics in a saltwater environment, and anyone that's spent enough time at sea on boats knows those two things don't necessarily always tie in together. The ability to actually come down and physically throw a switch to make that connection between two items, especially for critical items here as well, such as ventilations and bilge pumping and those sort of elements as well. Super important.
Yeah, absolutely.
So moving across a little bit here, we've got earth fault meters on here as well.
Yeah, so they've got meters for AC and DC earth fault monitoring. So as you'd expect at the moment, then neither of those are showing any issues. But if you did have, let's say that in time there was a connection came loose, something had been worked on, and there was a loose connection or something like that, whatever else might be causing an earth fault on either of those systems, you would see that registered on here with an alarm on the monitoring system, and that allows you to see the extent of the fault, but also helps in the sort of the diagnosis and solution of that.
Good stuff. I mean, I see we've got down here as well on the DC system. Again, this is one you guys are probably going to struggle to see slightly, and we'll get some tight shots of that. But really nice to see all your pumps on individual switches here as well.
Yeah, bilge pump, fuel pumps, black water pumps, all of the pumps there. So you can get to them quickly if you need them. And like I said before, you can see the sort of the status of things just at a glance. So this is that's the sort of distribution side from in terms of how that power is being supplied. Again, this is the central hub for this. So you've got sort of a shore power panel here. So at a quick glance from that panel, you can see, right, okay, so currently the shore power is connected for both supplies, but you can also see there if that circuit was to open for some reason or if it had tripped for some reason. Yeah. And again, your automatic and local control, another manual backup there. And that comes with these displays here that tell you, again, a second source of viewing of what your voltage is, frequency, what you're drawing.
So you've let the cat out of the bag, Jim. We are quite clearly tied up to the dockside here. We're not making our way across to the Caribbean, unfortunately. But, say we were at sea, we're going to need power for a variety of things on board. I know we're going to go into a bit more detail on some of those elements, regards batteries and things further down the line. Probably should address the two big white boxes that we've got here. Pretty standard system that we've got.
So yeah, we've got two Kohler generators here. They are each 28 kilowatts. and the generators are powering the board via the Victron Quattro inverter chargers.
Yeah.
So they allow through a AC input as well as inverting or charging.
They've got a pass through on them as well.
Right.
If you've got any issues with the inverters, they're going to be able to.
So you can bypass that.
Yeah, brilliant.
So for instance, if you have an issue with an inverter and you want to run a generator, or your shore power, there's a bypass mode where you can completely bypass those, and you lose some of the smart functionality that the inverters bring, but ultimately you can connect a source of power to your board. So that's a nice, straightforward but robust system there.
And some of the things that are nice to see with these gen sets, I mean, obviously they're in really sturdy, sound insulated boxes here to help with kind of noise and vibration. But what I really like to see on these as well is you've got so many means of controlling the generators, again, back to that level of redundancy and having direct control. Again, we'll probably get some tight shots of this, but you've got your main control panel here, which is literally mounted to the generator itself.
Yep.
We've also got some small control panels up here.
Yep, and on the bridge.
And then we've got a similar one on the bridge as well. And then obviously...
And then through the IMAX controller monitoring system. So that would be, these are normally set to remote operations. So you can go into IMAX and you can either manually start them, or there's a mode so you can set them to automatically start if your batteries drop to a certain level. There are various ways of controlling them. But again, fundamentally, if that all were to fall over for some reason, you've got a Kohler panel that's directly connected to a Kohler generator in various places, and as you pointed out there, ultimately the panel on the generator itself.
There's fantastic access from these as well. I'm not going to open everything up, but the ability to actually remove each one of these panels super quickly and easily, a couple of clips here, and then actually remove all the paneling, and being located as they are here, again, for a vessel this size, you've got some brilliant all-round access to these.
You can completely strip this cover down and get to it from any angle. So that certainly helps from an engineering perspective.
Yeah, definitely keep the engineers happy. That's a good thing, isn't it? Great. Should we move around to another section in the engine?
Sure. Yeah.
So Jim, moving on to something really quite important for any vessel covering large distance, but specifically around explorer vessels operating in remote regions. Drinking water, that's about the most important thing we need to survive as humans, right? So we've got a couple of days or so without water. So if we're up in Svalbard or something along those lines, not necessarily going to be able to go and tie up to the dock. We need to be able to make our own water. So like a lot of vessels, we've got these water makers, reverse osmosis plant, desalination unit, however you want to refer to it. And we've got two systems on here as well.
Yeah, so it's all packaged as one duplex unit, but there are two identical water makers here, so everything is duplicated. So again, back to the redundancy. If one of these were to be in maintenance or to have gone down for some reason, you have the whole. You still have 100% of that of your required capacity. So each of these is 270 litres an hour capacity, and you can run them manually, you can run them automatically. Everything's controllable here, either sort of via a digital system or manually. And it's just a nice, relatively simple, robust unit. It's a Cafalco, and we really like them. You see them in a lot of long-legged cruising yachts, and that's one of the reasons we've chosen them.
So one of the things I like about this system as well, having used these a little bit, is you've got the ability to control everything just from these simple touch panels, right? You can flush the system. So some of the challenges around water makers generally are, we all know how sensitive those membranes can be, and if you're not looking after those membranes in the way that you should, that's where you can kind of get a bit let down. So some of the flushing systems, I know you've got auto flush, but can you flush these manually as well?
Yeah, you can. This has, as you say, this has auto flushing. That's how it's set up at the moment. So It's connected into the boat's freshwater ring main, and then has the carbon filters on that just to make sure that you're getting a nice clean water that you're flushing the unit with. And you can then configure how often you want to do that. So at the moment, this is set every 3 days to flush for 2 minutes. And the captain may decide to change that depending on how he's operating the boat. And it's up to him really as to whether he wants to run them both at the same time or run one day, one the next, to keep everything running and keep the membranes happy. Or he might decide to put one half of it out of service until such time as it's needed. It's really up to him and the owner. So plenty of options there.
And it's great to have that backup as well, right? The number of thinking back to some of the examples I've had in the past where we've actually had to divert from crossings in the past because you've got maybe just enough water in your tanks to actually make it there safely. But if your water maker goes down, you haven't got the option. There's no extra contingency factor in there as well if you have contamination within your tanks. So to have that reassurance of a twin system and a kind of dual redundancy certainly gives me a lot of reassurance, especially when you go into the back and beyond, right?
Yeah, and when you couple that with the fact that we've got 2 big water tanks up forward, combined capacity of about 6,000 litres. Yeah. You've then got a specific 200-litre drinking water tank, so that only ever sees water that's come from the water maker or from the water purifier. You're pretty well covered there in terms of reserves as well. And again, so any water coming out of this or any water coming from anywhere, any supply is going through various filtration. It's going through a silver ion sterilizer, and then it's ultimately coming through a UV sterilizer before it comes back to you out the tap.
So UV on the way in, goes through the system, through your body, UV on the way out. So it's as clean when it goes out as it does when it comes in.
Yeah, so that's the water maker.
Excellent. Cool, so we've moved around to the starboard side of the engine bay now, Jim, and we're looking at in general at the HVAC system. I want to start off by just discussing our chiller units here for the aircon. So can you take us into a bit of detail with some of these, please?
Yeah. So there's a centralised chilled water system, a tempered water system, so whether that be in heating mode or chilling mode. And these are Dometic variable speed chiller units, capacity 72,000 BTU.
That's pretty good.
Per hour each. And then depending on whether you're in summer mode or winter mode, these are either working on chill mode for your air conditioning to all your air handlers around the boat, or they're working on reverse cycle heating mode, pumping hot water around the boat to your air handlers. They also work in combination with the boiler and the calorifier. So these units all kind of work together to so you can, if you're in a region where you just need a sort of a low level of heating, you can work on reverse cycle mode. You can then supplement that with the diesel boiler.
So we'll come on to the boiler. Just so with regard, I mean, obviously we've got the 2 systems here again. There's a bit of a theme developing on these Arksen vessels, right? You've got some good redundancy built in. Just from my understanding, say you're out in the Red Sea, for example, and it's kind of mid-40s in terms of temperature. I'm assuming there's going to be times where you're probably going to be running both your chiller units to try and cool the air as best you can.
Yeah, so if you're somewhere where it's really hot, if you're in the tropics, you'd be running both of these. But you might find that if you're somewhere where it's hot enough to need air conditioning, but not really, really hot, you could be running on one, and then they're variable speeds. So,
like an English summer, for example.
Right, there you go, yeah. That rare thing. So they'll ramp up and down as needed. So that's where a lot of that efficiency comes in.
So that's great when you're operating in hot, humid climates, etc. A lot of owners and of these type of vessels, part of the reason you get a vessel like this is to be able to go and explore places like the high latitudes and the polar regions. Gets a bit chilly up there, doesn't it? So obviously you've got a good reverse cycle system here that's going to run off the same system you'd run your air conditioning off, much as you would with the domestic system. But we've got these, we have a diesel boiler system as well. Now, for those that might be familiar with smaller vessels and a simple diesel heater you have on those, you might have air passing across a heat element and then that air is pumped directly around the boat. you start to get to bigger systems like this, can you maybe just dive into a bit of detail for those that aren't familiar with a diesel boiler as opposed to just a standard diesel heater and how that integrates to the heating system in general?
Sure. Yeah. So we've obviously talked about the reverse cycle, and this diesel boiler can be used to supplement that, or can operate on its own, which is how it's been running while we've been alongside here. It's it's been sort of -3 this morning, and it's perfectly capable of doing that. And rather than blowing hot air, this is heating water. So there's a heat exchanger onto the tempered water circuit that we talked about with the chiller plant, and this is basically using a diesel-fired boiler to heat the water going through that heat exchanger to in turn heat the water in that tempered water circuit.
Yeah, okay, that makes sense. And I've got to say it was pretty effective this morning. It was about -3 on ice on the pontoons. Fired it all up this morning, and I think 10-15 minutes later we were seeing kind of 20-25 degrees within the cabins.
Yeah, really effective.
Yeah, it's impressive stuff. And then moving a bit further around, we're coming on to the calorifier unit itself. Okay, so big tank in here, water. Why have we got this? Are we talking? Is this the same as having in your airing cupboard at home?
So the calorifier is 200-litre calorifier. It works from the boiler as well. So the heat exchanger to allow the boiler to heat the water in here, and the water from here, it comes from the fresh water on board, heated up and then circulated around the boat as hot water to the various outlets. So as well as being able to be heated by the boiler, this can also be heated by immersion heaters. So if you're on shore power, for instance, there are 2 6-kilowatt immersion heaters in here. So they're pretty high power.
Yeah, very high.
You may decide that you don't want to be using that much power, so you can use your diesel instead. But it depends where you are, what you're doing. But there's a couple of options covered there. So there's redundancy in the electrical heating, and then there's redundancy in terms of the fact that you've got the diesel boiler and the electrical heating.
Yeah, and it's nice you've got 2 elements in here as well. So what you say these are 6 kilowatt?
6 kilowatt each.
Each, goodness, yeah. So I think even if you just had one of those running, you're gonna be heating up that couple of 100 litres quite quickly. Really, it's a big kettle.
Yeah. We've not managed to run out of hot water yet.
Brilliant. Getting into the meat of the propulsion now, Jim, and how this vessel makes way. So, a couple of main engines I can see here. Got drive shafts, gearboxes, etc. So maybe if we just go through, let's talk about port engine. What engines have we got here? Give some of us some of the juicy specs.
So it's a Scania. So the Scania engines, they're the heavy duty commercial engine. You see them on a lot of commercial craft. They're really well supported globally. 5-cylinder inline diesel. And this particular variant is a continuously rated variant, so you can run it 100% load, 100% of the year, no unlimited hours per year at full power.
Brilliant.
So ultimately for an owner, if they need to get somewhere quickly, whether that be because they've got an emergency and need to get back to port, or if they're trying to work around weather, etc., if they wanted to, they could just go flat sticks and have no issues with engine warranty or anything like that.
What are they rated to in terms of power output?
So these are 350 horsepower each.
Okay, so I think that's really interesting to hear. You see the shots of the boat, big vessel, 350 horsepower each. Doesn't seem like a huge amount. What allows us to get away with using what might be considered sort of or lower power output engines in comparison to similar vessels?
It just comes back to the efficiency of the hull. It's a slender hull, highly efficient design. Really just doesn't require a lot of power to push it through the water fundamentally.
And that reduction in sort of size and power, how does one of the beautiful things about these boats is the range. As far as I'm concerned, they're really class topping in terms of a boat this size and how far she can go. So, in terms of the power output versus the range, smaller engines, more efficient.
Yeah, it's the right. What's important is it's the right size of engine for the boat. That we're not trying to. We frequently get asked, well, but what if I put in an engine with more horsepower? And the answer is, well, you you can put in a lot more power to get a little bit more gain, but you very quickly come up against a point in the power curve where it's just not it just doesn't make sense. And so, for instance, we looked at putting the 400 horsepower variant of this same engine in, and you got, I think it was a 0.2 of a knot or something like that, maybe if you're lucky. But then you're then into an intermediate duty engine, which for some people is still a commercially rated engine. For a lot of people that would still be fine, but for some people then that might sow a little seed of doubt as to whether it's the right choice or not. So,
and more fuel burn as well, right?
Yeah.
You go up in capacity, you go up in output, you're going to be burning more fuel for, you come up against those diminishing returns, don't you?
Yeah, and ultimately, the whole idea is that most of the time you're going to be cruising at the sort of 9 to 11 knot speed range, nice and efficiently, and you've still got that 14 knot speed if you need it. So that, I think for a lot of people that's going to be the main thing.
And there's obviously this is one engine option we've got within the Arksen range. You've got the sort of standard spec, as it were, with your two highly efficient, continuously rated diesels. And I know we'll come on to in subsequent videos a little bit about the hybrid propulsion system as we got on the other boat in build at the moment.
Yeah. So a lot of interest on in the comments on the walk around video about the hybrid option, and it's definitely something we intend to release. And we're in the final stages of building that boat, and at the appropriate time we'll do similar videos for that. And
looking forward to getting on the water with that one.
Lots
Should be fun.
Lots to look forward to there for sure. But yeah, hybrid versions. We can offer other engine options if people want them.
Say if they have a preference, for example, if they're used to Caterpillars or something along those lines.
Yeah. So for instance, we know that we have a Cummins option that is almost a like for like change for the Scanias.
Right.
And it really it depends what people's preferences are and that sort of thing. So.
But will they be red?
They can be any colour you want them to be.
Brilliant. Okay. So obviously, 5-cylinder diesels, a couple of those. Drive system, off the back of the, off the forward end of the engine actually. We've got our output shaft here going into a V-drive gearbox.
So it's a remote V-drive. So there's a short carbon shaft between the engine and the gearbox. And then the gearbox then has another carbon shaft between that and an Aqua Drive thrust bearing. So it's a remotely mounted thrust bearing, and idea being that is rigid, that is securely mounted to the structure of the boat. All of the thrust in the shaft is taken by that. It reduces the load on the gearbox. It reduces the associated noise and vibration.
That's a big one.
It gives a little bit of more flexibility, in terms of how we can mount the engines and gearboxes as well. Makes a lot of sense.
In terms of who we needs to run on one engine for any reason, again, sort of extended period, you might want to do some inspection or looking at some items. So if you were running on one engine, obviously you want to try and avoid that situation where you've got a gearbox spinning without any oil pressure, etc., running through it. So shaft brakes, we've got some shaft brakes on it.
Yeah, so we were looking at shaft brakes versus trailing oil pumps, and we decided in the end that the shaft brakes, the way to go. If you're for that rare case where you do find yourself in a position where you want to cruise on one engine, you can just lock the shaft off. It's a manual shaft brake, is basically a heavy duty disc clamped to the shaft, and then with notches in it and an assembly so you can manually wind sort of a spigot into the recess on that disc to lock the shaft off, and that's going nowhere then. And we've obviously used that on trials and motoring around at full speed on one engine, and it doesn't.
What sort of pace out of interest were you making on one engine? Do you remember off the top of your head? I put you on the spot here a bit, Jim. Sorry.
We were still like north of 9 knots.
Goodness, I mean,
I can't remember specifically, but it was really impressive.
Pretty impressive, actually.
Yeah. And then so from the shaft brake, the shafting itself is 80mm duplex shafting, so that's designed to Lloyd's requirements. And those shafts are reversible, so if you get to a point way down the line where you might be seeing some wear on your shaft, for instance, you can just take it out and turn it around and put it back in again, and you're off on your way. Which, if you're somewhere remote, you combine that with the fact that you can dry the boat out on its skegs. You could be somewhere really remote, dry the boat out, and
and if you're prepared and you know what you're doing, you could do that in that period.
And so that actually brings me on to another point. We talk about everything that's happening inside the hull at the moment. In terms of stern glands for the prop shafts coming out the back of the boat, standard deep sea seal.
Yeah, Tides Marine seals. So yeah, quite a commercial seal. Just no maintenance. Nice and simple. Water lubricated. So there's a feed of used cooling water from the gearboxes that goes off to those. And then the spare sort of seals are then clamped to the shaft in place, ready to go.
So as a point I wanted to come on to actually was with the stern glands. So rare, I appreciate, but as someone who's suffered a few times from stern gland failures, you can get quite a lot of water into the boat quite quickly. Sort of, what contingency have we got there for a failed stern gland?
In the first instance, you can change the seals, so those stern glands are set up so that you can really easily remove a seal and then slide the spare one, which is already on the shaft, into place. And you'll get a bit of water coming into the boat while that's happening.
But it's there. You've got the second seal prepped, ready to go. You're not going to be taking on water for a huge period of time.
Correct. Yeah.
Which is a really nice touch, I think. And then just sort of moving outside of the boat then. We touched on the skegs already, so the design of the skeg and the ability to, should you need to take the bottom and let her dry out for a period of time, so the structure within those. And the propellers themselves, so this was something interesting I found when I first came with the programme. I'd sort of assumed there was going to be some sort of clever variable pitch type system to the props, and pretty sort of standard fixed pitch props on this boat.
Yeah, we looked at variable pitch as an option, and just decided actually that we prefer to keep it simple and keep with fixed pitch. With the combination of engine and gearbox and propellers that we've got, there's a really nice formula there. So we decided just not to add the extra complexity, the weight that comes with that, the space requirement. The space requirement can't be underestimated for variable pitch props.
So what sort of, with the fixed pitch prop here, you're saying that they're quite large diameter, aren't they? So we got a relatively slow turning engine. What sort of ratios are we looking at on the gearbox?
2.96 to 1. So
right, okay.
So when you combine that with an 1800 RPM engine, we can then have a propeller that's just over 1 meter in diameter.
Yeah.
It's 5-blade. Fixed pitch, made by CJR, local company to us, and they perform fantastically on trials, and really pleased. And
I think from certainly boats I've worked on with variable pitch props, it's lovely. It's a great idea in, and don't get me wrong, I think they definitely hold their place, but it is a huge layer of complexity of something that's happening outside, underneath the water. It's almost a case of kind of when they're going to go wrong versus if they're going to go wrong, and
lots of moving parts. I agree.
And in pretty inaccessible parts of the world as well. And I guess being such a low displacement and slippery hull, actually the requirement to kind of, as you might do with a heavier vessel, of kind of having that real fine pitch to get it moving and then moving into the coarser pitch, doesn't really seem like a requirement for this. And if it's not needed, don't do it, right?
Yeah,
Keep it simple.
And these boats will typically be cruising long distances at set sort of RPMs, and so we've got a design point to our propellers that is matched to our sort of typical half load cruising displacement, and the sort of those sort of efficient cruising speeds. So that's the way we've gone.
Great stuff. So, having talked through stuff on the engines, they're going to get pretty warm, these things here. I think probably what the people want to know about at home is some of these sea chests and raw water cooling system. It's quite steampunk looking at all this down here, isn't it? So I'm just going to move my position a little bit here so we can get a slightly better view.
Yeah, we love to show off the quality of the pipe fitting on this boat.
Yeah, it's a nice bit of kit actually. It's very nice. So we've got you've got your two main sea chests here and sea strainers for port and starboard. Before I make a fool of myself and talk about the raw water cooling system, Jim, can you just sort of run us through some of what led you guys to decide on this particular system?
Yeah. So the reason we have these 2 large strainers is we decided that each strainer should be fully capable of providing the cooling water for everything that needs cooling water.
Right.
So we typically run with one of these closed. You could run with them both open if you wanted to, but at the moment we're set up that one of these here is closed and one is open, and you can run everything at full capacity like that. It just means that if you've got a strainer that gets blocked for some reason, similar to the fuel discussion we had previously, you can just shut one, open the other, and carry on basically, which is a good, I think, a sensible thing to do.
What I really appreciate as well is, again, the ease of access. If there's something you ever need to shut in a hurry, it's probably going to be your raw water inlets, right?
It's one of the biggest holes in the bottom of the boat.
Exactly. And I love the fact that very easily you can come around here and you're straight onto these valves. There's no leaning over gantries and reaching down into bilges. I think that's a really important feature.
And we've tried to centralise this as best as possible. So we've tried to minimise the number of hole penetrations we have throughout the whole boat. So the vast majority of seawater requirements for the boat, whether it be the engines, the generators, the sewage treatment plant, the water makers, whatever, are fed from these. So there's the sort of the main manifold you see in the middle here, which everything is taken from. You can run anything off either of these strainers the way it's set up, and then there are a couple of big seawater pumps just under our feet here that feed the auxiliary seawater circuit. So there's a pumped seawater circuit that everything else is fed from.
Okay, so just for clarity here, with one of these open, you could be running both mains, both jennies, have water coming in for your water maker, any sort of ancillary systems, all through one sea chest, right?
All through one sea chest at full power.
That's that's pretty impressive. You certainly concerns about putting up chunks of ice and things like that as well, and kelp and.
You can really clear as you're just walking into the engine room. You can really clearly see the inside of your strainers. You can straight away see if there's any debris building up on there, or if there's possibly a blockage.
Nice to be able to, as well, if you are in that situation, to be able to not have to shut things down. If you're starting to see a bit of reduced flow or something, you can pop the other valve open, and quite quickly. There's a fair few wing nuts on there that need taking off, aren't there? But you can get into that and clear out the strainer, no problem at all, right?
Yeah, and then you'll see here we also have valves on top of the strainers, so that allows to bleed out any air that if any air sort of becomes trapped in there, you can bleed that out. But there's also an airline connection on there, so if you wanted to purge the strainers, if you had some weed in there or some ice, you can attach a wandering airline to that, and very very carefully, obviously with compressed air, you can use that to purge those strainers out. And the lids are set at a height as well, so that the water line of the boat, in its deepest draft condition, is just below the level of the lid.
Yeah, so where we're looking somewhere like here or something.
Just under, the water would be just starting to lap.
So you could have these valves open, and actually, not that I would recommend this to anybody, but you could actually have the caps right off those. Yeah. And just purely by physics, you're above the water.
You can rod them out. You can take a lid off, and if you've got a blockage, you can remove the basket, and you can get a broom handle down there and rod out any blockages. Yeah, you'll get a little bit of splashing, but you probably won't care about that if you've managed to sort out your blockage.
Definitely.
And then on that sort of auxiliary pumping system, either of these pumps are capable of pumping that system. So if one of these were to go down for some reason, or if you were to take one out of service, you can still run everything quite happily on either one of those. It's also the same pump as the fire pump. So if you had run out of spares, for instance, or you had a problem, and you weren't going to be able to sort it in the short term, if you were somewhere remote, you've got an option there to sort of share parts or replace a pump completely.
That's a really nice touch.
And there are 2 fire pumps, so you wouldn't necessarily have an issue with taking one of those out of service.
Fantastic. Well, Jim, I've certainly learnt a bit today.
Good.
Thank you very much for your time, and I hope you guys at home have enjoyed this as well. So If you want more content like this, you know what to do. This video came out of some comments that we had on the page. So if you have further additional questions for us and things you'd like to cover, please don't hesitate to comment, share this with your friends, give us a like, help us out with the YouTube algorithm. We'd really appreciate it. See you on the next one, guys. Cheers.
Cheers.